Now we're going to take up one more problem. The problem number 39. A beam of 25 meter long is supported at A and B and is loaded as shown in the figure. Draw the SFD and BMD for the beam, computing shear force and bending moments at A, E, D, B and C. Find the position and magnitude of the maximum bending moment. Also, determine the point of contraflexure. So first, we want to have here a 10 kilonewton per meter between A and E having a span of 10 meters. Then a 20 kilonewton acting downwards at the point D, which is 15 meters from A. And then you have a support reaction at the point B, which is 20 meters from A. And we have 30 kilonewton, which is acting at the point C, which is 25 meters from A. Now we need to find out the reactions or the support reactions. So by taking the moments about the point A, that is RBV into 20 will be equal to 10 into 10 into 10 by 2 plus 20 into 15 plus 30 into 25. Therefore, on simplification, RBV will be equal to 77.5 kilonewton. There also we know the sum of the vertical reaction acting upwards will be equal to sum of the vertical reactions acting downwards. Also RAV plus RBV will be equal to 10 into 10 plus 20 plus 30, which will be equal to 150. Therefore, RAV will be equal to 150 minus 77.5, which will be equal to 72.5 kilonewton. Now we will going to take the shear force diagram. SF at A will be equal to plus 72.5 kilonewton and SF at E will be equal to plus 72.5 minus 10 into 10, which will be equal to minus 27.5 kilonewton. Between E and D it remains constant. SF at D will be equal to minus 27.5 plus 20, minus 20, which will be equal to minus 47.5 kilonewton. Between D and B, it remains constant at minus 47.5 kilonewton. SF at B will be equal to minus 47.5 plus 77.5, which will be equal to 30 kilonewton plus. Then between B and C, it remains constant at 30 kilonewton. SF at C will also be equal to plus 30 kilonewton. So you can see here, SF at A is 72.5 and it reduces to minus 27.5 kilonewton due to according to the equation of straight line due to UDL. Between E and D it remains constant, and at SF at D, which will going to be 47.5 kilonewton, sudden variation due to point load. Again, between D and B, it remains constant at minus 47.5 kilonewton. Sudden variation due to point load, it will going to increases to plus 30 kilonewton. Between B and C, it remains constant at 30 kilonewton. Then SF at C will be equal to 30 kilonewton. Now we will go for the bending moment diagram. So BM at A will be equal to 0. BM at E will be equal to plus 72.5 into 10 minus 10 into 10 by 10 into 10 into 10 by 2. So on simplification, you will going to get it as plus 225 kilonewton meter. BM at D will be equal to 72.5 into plus 72.5 into 15 minus 10 into 10 by 2 plus 5. That will be equal to plus 87.5 kilonewton meter. BM at B will be equal to 72.5 plus 72.5 into 20 minus 10 into 10 by 2 plus 10 minus 20 into 5, which will be equal to minus 150 kilonewton meter. BM at C will be equal to 72.5 into 25 minus 10 into 10 by 2 plus 15 minus 20 into 10 plus 77.5 into 5, which will be equal to 0. So this is how you will be able to get the bending moment diagram. But BM at A is 0 and BM at E is plus 225 kilonewton meter. So you cannot join from 0 to 225 because SF is changing its sign from positive to negative at this point, which is F, and where SF changes its sign from positive to negative, I need to find the maximum bending moment. At that point, you will going to get the maximum bending moment. Therefore, we cannot join between these two now. Then between SF at D will be equal to 87.5 kilonewton meter. So join between 225 to 87.5 kilonewton meter. Then between 87.5, it drastically reduces to minus 150 kilonewton meter. Again, it is changing its sign from positive to negative here, from 87.5 to minus 150 kilonewton meter. Then again from 150 kilonewton meter to 0 at the SFBM at C. Therefore, here between A and D, when you want to join, it is going to be joined by the equation of parabola. BM varies from 0 to plus 225 kilonewton meter according to the equation of parabola. BM varies from 2 plus 227, 225 plus 87 to 87.5 kilonewton meter according to the straight line. Then again from plus 87.5 to minus 150, equation of straight line. From minus 150 to 0, it will be equation of straight line. Now we will going to have the maximum bending moment where SF changes its sign. SF changes its sign at B and F. Let the distance of point F be at x meters from C. So then what happens? SF at F will be equal to 0, that is equal to plus 72.5 minus 10 into x. Therefore, x will be equal to 7.25 meters from C. BM at F will be equal to 72.5 into x minus 10 into x by 2. As the value of x is 7.25, therefore that will be substitute the value of x as 7.25 meters. In other words, it will be plus 72.5 into 7.25 minus 10 into 7.25 into 7.25 by 2. On simplification, you will going to get it as 262.8125 kilonewton meter. So at the point F where SF changes its sign, it will be 7.25 meters from A, and also at that particular point you will going to get the maximum bending moment, which is 262.8125 kilonewton meter. Then join between 0 to 262.8125 and from 262.8125 to 225 kilonewton meter. Join these 3 points by means of a parabolic curve because it is having the variation is UDL. Now, the maximum positive bending moment is at the point F, which will be equal to plus 262.8125 kilonewton meter, and maximum negative bending moment is at the point B, which will be equal to minus 150 kilonewton meter. Because these two are where the SF changing its sign from positive to negative and then from negative to positive. Now we go for the point of contraflexure. It is the point where the bending moment changes its sign from positive to negative, which is at the point G. So the point of contraflexure is at G. Let the distance of the point G be y meters from C. So that will be equal to BM at the point G will be equal to 0. That will be equal to minus 30 into x or 30 into y plus 77.5 into y minus 5. Therefore, expanding this minus 30 into y plus 77.5 into y minus 387.5 will be equal to 0. So when you take 77.5y plus minus 30y, it will be equal to 47.5 into y equals 387.5. So on simplification, y will be equal to 8.1575 meters from C. Therefore, the point of contraflexure at G will be equal to 8.1579 meters from C. So this is how you will be able to analyze the point of, able to find out the point of contraflexure and also the maximum bending moment at the point F, and also the bending moment diagram and the shear force diagram, and we will be able to find the support reactions. So thank you.